Switching transistor photo relay control. 24-volt DC 4 Hz pulse circuit design. MCU-Soft version part 3. What you will learn in this video. Pulse switch block design. Design a photo relay control circuit using a switching transistor. Design a photo relay control circuit, pulse switch. This video is part of the 24-volt DC 4 Hz pulse circuit design MCU-Soft version. If you watched part 1, please skip to 4. Create a schematic, or 5. Design of each block circuit. Welcome electric design of the ST.bonbori channel. I will post about the switching transistor and photo relay control. This video is part of 24-volt DC 4 Hz pulse circuit design MCU-Soft version. I think there are several ways to achieve electric design even for circuits with the same specifications. Regardless of whether it is hardware or software, I believe that the strengths and weaknesses of this method, the personality of the designer, and the experience of the designer will appear. In this video, I would like to explain one of the design methods. Next, I will explain about the table of contents in this video. The table of contents of 24-volt DC, 4 Hz pulse circuit design, MCU-Soft version is from 1 to 9 items. 4. Create a schematic. 5. Design of each block circuit. Part. Design a photo relay control circuit using a switching transistor. Design a photo relay control circuit, pulse switch. 4. Create a schematic. In the TI editor, enter the parts determined by each block. The yellow symbol indicates a new creation. There is no SPICE library. Enter the main parts. Terminate the wires including passive parts, resistors. It is a circuit composed of 4 blocks. Voltage drop. Pulse generation. Pulse switch. Lighting. In part 3, I will design a 4 Hz pulse switching circuit. 5. Design of each block circuit, pulse switch. The following are 4 formulas that can be used as a reference when designing circuits. Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law. Calculating power consumption. Please subscribe to my channel, and if you like it, please thumbs up. It will encourage me to create the next video. 5-3. From 3.3-volt DC to 24-volt DC pulse switch design. For example, what is the circuit that controls the 24-volt DC and 4 Hz pulse at 3.3-volt DC? 1. Controlled by logic IC cells and photo relay. Hard version explained. 2. Controlled by switching transistor. 3. Controlled by switching transistor and photo relay. 4. Controlled by switching transistor and photocoupler. For this video, select number 3. Controlled by switching transistor and photo relay. 5 to 3.1 Controlled by switching transistor and photo relay. Resistors are connected in series and a switching transistor controls the current and voltage of the photo relay. Design the value of the resistor. The calculation formula is as follows. The resistor R was set to 2, R1 and R2. Next, I will explain the part datasheet to determine the resistor values. 5 to 3.2 Determining the value of resistors R1 and R2-1. The specifications of the PIC 16F1778, transistor 2SC1815, and photo relay TLP241A are shown below to determine the resistance value. PIC 16F1778 from data sheet. Output high voltage VOH, minimum 2.6 volt. Output high current IOH 3 mA. Output low voltage VOL, maximum 0.6 volt. Output low current IOL, minus 6 mA. Next, I will explain about datasheet of the switching transistor. 5 to 3.2 Determining the value of resistors R1 and R2-2. The specifications of the transistor, 2SC1815, for determining the resistor value are shown below. Transistor, 2SC1815, from datasheet. Base emitter saturation voltage VB 0.7 volt. DC current gain HEF maximum 100. Next, calculate the resistor value R. 5 to 3.2 Determining the value of resistors R1 and R2-3. Substitute a value into the formula, A, to determine the resistor value R1 and R2. Assume that the PB0 port output current IBR is 1 mA. IBR should be less than the PB0 port maximum high output current IOL 3 mA. Output high voltage, VOH 2.6 volt. Base emitter saturation voltage, VBE 0.7 volt. PB0 out current, IBR 1 mA. To calculate the resistor R. Calculation result are 1.9 kilo ohm. I chose two 1 kilo ohm resistors, R1 and R2. Next, I will explain the RBO port output current IBR value when the resistor R is 2 kilo ohm. 5-3.2 Determining the value of resistors R1 and R2-4. Recalculate the RB0 out port current IBR value when R equals 2 kilo ohm, R equals R1 plus R2. Use the formula -A to calculate the PB0 output port current IBR value of the PIC. Output high voltage, VOH 2.6 volt. Base emitter saturation voltage, VBE 0.7 volt. Resistor R 2 kilo ohm. To calculate the PB0 out port current IBR. IBR equals 0.95 mA. This is the design value of the IBR. Next, I will explain the pull-down resistor R7 for noise suppression. 5-3.3 Add R7 pull-down resistor. For noise suppression, a resistor is connected between the base and the emitter of the T2 transistor to create a circuit that directs noise to the ground side. T2 switching transistor malfunction prevention. 1. A pull-down resistor R7 equals 10 kilo ohm is added for noise suppression. In this circuit, there is also a two-path of noise flow. 2. When the RB0 CMOS out port is at low level, noise flows to the PIC side. Next, I will explain the IB and IR currents which branch off from the RB0 output port current IBR. 5-3.4 IB and IR current calculations. The IBR current is bifurcated into the IB current and the IR current. Calculate the IB and IR currents. Calculate the current IR flowing through R7 using equation B in the red frame. Base emitter saturation voltage, VBE 0.7 volt. Resistor, R7 10 kilo ohm. To calculate the current IR of R7, IR 0.07 mA. The base current IB is calculated using the red frame formula, C. The base current IB value is calculated by subtracting IR 0.07 mA from IBR 0.95 mA. IB equals 0.88 mA. The design values are IBR equals 0.95 mA, IR equals 0.07 mA, IB equals 0.88 mA. Next, calculate the power dissipation of resistors R1, R2, and R7. 5-3.5 Checking the power consumption of R1 and R2. Calculate the R1, R2 power consumption. R1 or R2 equals 1 kilo ohm. Power rating equals 0.5 watt. 1. Calculate the maximum current IBR. Calculate the IBR current using the red frame equation. IBR equals 1.45 mA. 2. Calculate the R1 power consumption. Calculate the power consumption of R1 using the red frame equation E. R1 equals 2.2 mW. It was confirmed that the power consumption of resistor R1 was less than the power rating. The same is true for R2. 5 to 3.6 Checking the power consumption of R7. Calculate the R7 power consumption. R7 equals 10 kilo ohm. Power rating equals 0.5 watt. 1. Calculate the current IR. Calculate the IR current using the red frame equation, F. IR equals 0.07 milliampere. 2. Calculate the R7 power consumption. Calculate the power consumption of R7 using the red frame equation, G. R7 equals 0.05 milliwatt. It was confirmed that the power consumption of resistor R7 was less than the power rating. 5 to 3.7 Photo relay control circuit. Resistors R3, R4 are connected in series to control the photo relay on or off. The value of the resistor R in the left figure is determined from the calculation formula, H. Two resistors R3 and R4 can be used as one. Next, I will explain the part datasheet to determine the resistor values. 5 to 3.8 Determining the value of resistors R3 and R4-1. The specifications of the transistor, 2SC1815, and photo relay TLP241A, are shown below to determine the resistance value. Transistor, 2SC1815, from datasheet. Collector to emitter saturation voltage, VC 0.1 volt. Photo relay TLP241A, from datasheet. Forward voltage, VF, 1.27 volt. Forward current, IF, 5 volt, minimum, 25 volt, maximum. Target current IF equals 10 milliampere. Next, calculate it from the values in this datasheet. 5 to 3.8 Determining the value of resistors R3 and R4-2. Substitute a value into the formula, H, to determine the resistor value R3, R4. Assume that the input forward current IF is 10 milliampere. Power supply voltage, VDD 3.3 volt. Forward voltage, VF 1.27 volt. Collector to emitter saturation voltage, VC 0.1 volt. Temporary forward current, IF 10 milliampere. To calculate the resistor R3, R4. Calculation result are 193 ohm. I chose two 100 ohm resistors. Next, since the resistor R is determined, the IF current value is recalculated. 5 to 3.8 Determining the value of resistors R3 and R4-3. Recalculate the input forward current IF value when R equals 200 ohm, R equals R3 plus R4. Use the formula -H to calculate input forward current IF. Power supply voltage, VDD 3.3 volt. Forward voltage, VF 1.27 volt. Collector to emitter saturation voltage, VC 0.1 volt. Resistor, R 200 ohm. To calculate the input forward current IF. IF equals 9.7 milliampere. This is the design value of the IF. The IF is within the photo relay on specification. Next, I will check about the power consumption of the resistor. 5 to 3.9 Checking the power consumption of R3 and R4. Calculate the R3 and R4 power consumption. R3 equals R4 equals 100 ohm. Power rating equals 0.5 watt. 1. Calculate the maximum current IF. Calculate the IF current using the red frame equation I. IF equals 11.2 milliampere. 2. Calculate the R3 power consumption. Calculate the power consumption of R3 using the red frame equation J. R3 equals 12.6 milliwatt. It was confirmed that the power consumption of resistor R3 was less than the power rating. The same is true for R4. Next time I will post about the circuit design of each block. Thank you for watching. Please subscribe to my channel, and if you like this video, give me a thumbs up, because it will encourage me to create the next video.